Hello and welcome to the first physics video. Today we are going to be focusing on lenses on a broader topic of light and lenses. This will be part one. The most important thing we're going to be focusing on today is the lens equation. That is what hopefully you will all be able to understand and use by the end of this video. So here we're starting with a lens. Specifically, this is called a converging lens because, as you can see, it is convex. If you want to know what the opposite of that would be, which just for completion, I'm going to show you this, but you're very unlikely to know this for your A-levels. It looks like that. So rather than going out, it goes in, like that. And I'll maybe, if we're lucky, show you what that means, possibly in another video. So here is our object, and here is our lens. Very simple. If you're familiar with objects in your everyday life, which I have a suspicion that everyone watching is, you will know that you can see an object from any angle, provided there's nothing in the way. So what that means is there is light coming off that object there, 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 and so on and so on. But all we care about for now is the light that is going to come across and hit this lens over here. So what eventually happens is a lens essentially is something that bends light. Something like that. Just to give you a good idea. Now to give you a clearer and neater idea, we'll have a look at this one over here. So here's our object and here's our lens, and these are is how the lens bends the light when it comes off. Now, what we need to know. Very simple. This line here is called the lens axis. Write that down. And then, if you look at where the light rays coming off that have been refracted, they meet at this point right here. This point is very important. This right here is where the image is formed. So that's what we're going to call that. This is going to be the image. And this is obviously the object. So we're going to call this distance from here to here the object distance. We're going to call that U. It should be denoted for any exam board and all A-levels. This should be U for object distance. Then image distance is denoted as V. Very simple. It's worth noting, I'll get more on this later, but the value of the object distance is usually negative because it will be to the left of the lens. So everything to the left of the lens or on the side of the object is always going to be negative, but we'll get into that later. So lens axis here, not too important, and then object distance, image distance. Nice and simple. Okay, so what I want to get into next is what happens when we move the object away from the lens, more specifically the lens axis, because that is what we look at, because what we do is we imagine that the lens is negligible thickness. So the lens axis is all we ever need to worry about. So, as you can see, if we have an object here and we move it out here, these obviously look different. And what you can notice is closer, these lines are much steeper, and further away, much less steep. So what I want you to think about is what happens if we move the object so far away, let's say over here, then it's going to keep doing that. And what's this? If you zoom in, well, these are so unsteep, partly from bad drawing, but they might as well be parallel. And that's what we can see. We'll eventually get this. So here, all we've done is move an object further and further and further away. Now the incident light rays, eventually, they seem to be going parallel. And eventually they will be effectively parallel. So if you have an object on the moon, or in most cases just across the street, or even across the classroom, it won't take much, especially if you've got a small target or a small lens. If the if the object distance is much greater than the the length of the lens, that's not an official definition. Then these will effectively be parallel. Yes, parallel. And so what we have here is the object distance is u equals minus infinity. Remember I said the object distance is negative. Now the reason this scenario is incredibly important is because where the image is formed, remember this is the image distance, we have a definition for that. So for every lens has something called a focal length. And the focal length is where the image is formed when the object is at infinite distance away from the lens. So this is the focal length. And you can call this the focal point. But the focal length of the lens is what is important. Okay, so I'll take a step back there and I'll tell you that now we have all the values we need that are included in the lens equation. So it's only fitting that I introduce you to said equation. Hope you're all very excited. So all we need to do is, the lens equation is, we've got the image distance on one side. Normally that might be what you're trying to figure out, but obviously you can figure out anything with the other two. 1 over image distance equals 1 over object distance plus 1 over focal length. And there we are. This is the lens equation, and it will carry you through almost everything you need to know about lenses all throughout A-levels. Granted, it's not the largest topic, and there are a few more things that I will cover, but if you just like this, you will definitely get most of the questions right. Then again, there is still a wider topic of light, which you definitely need to know. However, very good news that this is the majority when it comes to covering questions. Right, so only fitting that we go through a practice. We'll go to our simple lens over here and we'll assign an object in image distance to work out a focal length. So we've got object distance of minus 2 meters. Remember it's minus because that's what the object distance is. If you want to think back GCSE's days, however long ago that may be, probably just last summer, you can see it as a vector. The direction here is it's minus 2, so it means it has direction, what minus means to the left and positive means to the right. So this is minus because it's technically a vector, and let's say this is going to be 1 meter to make it very simple. Alright, so now let's work out the focal length. Alright, so now we need to just rearrange the focal length. So to do that, first we'll do a simple moving u across. So 1 over image distance minus 1 over object distance equals 1 over focal length. Then obviously just flip this round to get focal length. Now we're going to have a big 1 over image distance minus 1 over object distance equals focal length, and there's our equation. Now all we need to do is plug our values in. So make sure that you're very careful with object distance, because just plug it in immediately. Just keep it simple, whatever it is, whether it's minus or not, just u equals minus 2. There are situations where the image distance is also negative, so be careful there. Alright, let's plug that in. 1 over 1 minus 1 over minus 2. 1 over 1, obviously 1. 1 over minus 2 is, well, minus a half, but then this is minus that, so that's plus a half. So here we have 1 over 1 minus, or plus a half, so that's 3 over 2. There we are. So 1 over 3 over 2. Flip that around. 2 over 3 meters. And there we have it. That is our focal length all figured out. Okay, so that process will essentially carry you. That will be what you do almost every time. But we're going to look at, for completion, one more thing for this video. What happens if you place the object to the focal point? Now I'm telling you that this is just going to be a simple reverse of the process that we saw before, where you've got an object at infinity and it forms a focal point. But just to prove that to you, we're going to put it in the equation, and also teach you something important about evaluating infinities. So in this situation, the object distance is at focal length and the image distance is at infinity. So this is now infinity. That's may still be uncomfortable working with infinities for some of you. So u equals, technically this will be minus the focal length because it's still going to be negative. And we know that this is, I believe it was 3 over 2, 2 over 3. Alright, so to prove this infinity, all we need to do is 1 over v equals 1 over u plus 1 over f. Right. So flip this around to rearrange v, and 1 over big, 1 over u plus 1 over f. Now, rather than substituting in the exact focal length, we know that this is in fact the focal length. So this equals 1 over minus 1 over f plus 1 over f. Now the more astute of you may have already noticed that this is just a number plus, well, minus by itself. So that gives you 0. Now, a lot of the time in A-levels and in A-level maths, as well as physics, you will get many questions such as evaluate, especially in maths, evaluate this equation at infinity normally, or 0. Normally just evaluate the equation, and that will tend to mean where do the interesting things happen. That tends to be at 0 or infinity. In this case it's at infinity. So there are obviously infinities involved here. So evaluate the equation for image distance equals infinity would be this. The simplest thing would be evaluate, because the object is what causes it, evaluate what happens when the object is placed at infinity, and then you would know to put this whole process in that puts out the image distance equals the focal length. Now here we're going to get 1 over 0. Now for those of you who don't know, 1 over 0 is infinity. And there we are. Now you know I'm not lying. This is in fact a reverse process. If anyone's uncomfortable with this, I'd just like you to imagine if you think what's 1 over a very big number, say 1 over, let's say 100, that's 1/100th. Well, let's take 1 divided by a smaller number. So 1 divided by 10, that's only a 10th. 1 divided by an even smaller number, 1, that's 1. So you see it's getting bigger. So maybe 1 divided by an even smaller number, 1 divided by half, that's 2. Or 1 divided by a 1,000th, then that's 1,000th. What, 1,000. And if you go 1 divided by a trillionth is essentially 0, and then that's going to give you a trillion. So the closer you get to 0, the much bigger the number gets, which is why 1 divided by 0 equals infinity. Now that's everything we're going to cover today. We'll still cover more on lenses next time. We'll look at virtual images, and we'll go on to look at just a bit more about how light works. Thank you for listening for today, and hope to see you all next time.